Hello everyone. In this video we are going to see some applications of Newton's laws of motion. In our previous videos we have learned the basics of Newton's laws of motion, which were threefold. And in the first one, in the absence of external forces and viewed from an inertial reference frame, an object at rest remains at rest and an object in motion continues in motion. And the second one tells us, when viewed from an inertial reference frame, the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. And this is how we explain the second law mathematically. And finally, the third law was given as this. If two objects interact, the force F1 to 2 exerted by object 1 on object 2 is equal in magnitude and opposite in direction to the force F2 to 1 exerted by object 2 on object 1. And this is how we express the third law of Newton mathematically. After this quick recap, let's see how are we going to use those three laws of motion in our engineering applications. But before going deep into the application, let's take a look at this box and table example and try to figure out what are the force interactions of this system. And to analyze the force interactions, let's isolate this box from our system. Since the box is standing still on the table, we don't have any horizontal forces. We only have forces in the vertical direction. We have the weight of the box, and we have another force which is applied by the table on to the box, which is called the normal force. Let's name this force as F table to box. What we did here was to isolate the systems, box and the table, from each other. This way we were able to represent the forces on the box alone. This pictorial representation is called free body diagram, and this is a very important concept in force analysis. The reason why we use free body diagrams is when we are analyzing an object subject to forces, we are interested in the net force acting on one object, which we will model as a particle. Therefore, a free body diagram helps us to isolate only those forces on the object and eliminate the other forces from our analysis. And this free body diagram can be simplified further by representing the object as a particle simply by drawing a dot. Let's take a look at two free body diagram examples from our textbook. In the first one, we have a chandelier hung to the ceiling with a chain. The first free body diagram is chandelier itself. It was separated from the system, and we can see the tension force of the chain and the weight of the chandelier here. And in the second free body diagram of our chandelier, we can see the chain, only the chain itself, and the forces acting on it. Here we have T double prime, which is equal to the tension. This one was equal to this one. And also we have T prime, just one prime here, which is also equal to the force T, the tension force here. The magnitudes of those two forces are equal, but their directions are in the opposite way. In the second free body example, we have a box being pulled by a young man, and those are the forces on that box, the box itself only. The box was isolated from the whole system. Here the force T is the tension force, which was applied by the rope. This is the weight of the box, and this one is called the normal force, which holds the box stationary in the vertical direction. The normal force and the weight of the box are equal in magnitude, but opposite in terms of their direction. Drawing free body diagrams can be tricky sometimes. Therefore, one requires lots of practicing to feel confident with drawing free body diagrams. Also, we are going to use free body diagrams in our every force analysis. You are expected to first draw the free body diagram of the problem. Without free body diagrams, you won't be able to solve the problem, which will result in 0 grade. So let's talk about how to approach the force analysis problems. First thing we need to do is to conceptualize the problem. Drawing a simple, neat diagram of the system will greatly help, and the diagram helps establish the mental representation. And in this drawing of the system, establish a convenient coordinate system for each object. So the first step is conceptualizing the problem. Do not hesitate to draw. Second thing we need to do is to categorize the problem depending on the acceleration. If the acceleration is 0, then the total sum of the forces on the system should be equal to 0. If the acceleration is different than 0, then the total sum of the forces must be equal to m times a. Third step is to analyze the whole system. We need to draw a free body diagram. Third thing we do is to draw the free body diagram of each object. Do not forget to draw separate free body diagrams for each object in systems containing more than one object. Then find the components of every forces. Then solve for the unknown components of the system. Finalizing the analysis. Be sure that your results are consistent with the free body diagram. And also check the predictions of your solutions for extreme values of variables. So by doing that, you can often detect errors in your results. So those were the basics of the force analysis. See you in the next video.